that makes me geek out a little bit. It isn't, these are the slides that, well, some of them don't make the cut for what is going on stage. So if I had an hour and a half on stage, I would use these slides because I think this is the most interesting part about what I've been, layering back almost like an onion to get to the core of why this number is super important. And if all things work out, I told my support group this morning at the Pin Chasers, that's the bowling alley where we meet and talk about, anybody wants to come have questions answered. It's free. We meet across the parking lot here in a place called the Pin Chasers in Tampa, and we do it every Tuesday morning at 8 o'clock. And it's free to the public. It's me doing some, answering questions and just trying to bridge a gap where your insurance is not going to pay me to teach you about this. YouTube is a wonderful place to get it for free, but I need human interaction for some of this. So selfishly, I practice my speeches to the folks that show up, and I get to ask them some questions, hear some of the frustrations, but also they get to watch me noodle through things, like how would I explain this? So we're going to pick up with some of this lecture, and I shared this morning with them that I have a boy crush. You're going to figure out who the boy crush is on by the end of this lecture, and maybe a little foreshadowing for next week. So let's get started on the lecture, and if you like geeky topics, I hope this is relevant, and I do want to hear some feedback on this as we dive into the topic and share with you what I think everybody should care about. All right, let's get started. All right, so this is a structure that most of you will not recognize. Most of you will not notice that this is a very powerful and important structure that is used to remove nitrogen from our bodies. And although you may not recognize the structure by sight, we all would recognize the structure by smell. This is a uric acid, and uric acid is the core structure, removing nitrogen from our body, removing waste from our body. And from the first time you change a diaper on a baby, you know that, well, you probably know it after taking care of animals. This smell of urine is very key, and it is the smell of nitrogen being removed from our body. If you stop doing this, you die. It is a very important process, but it's also not very sexy. You talk about uric acid and people are like, why are you talking about that? In my little slides, I try to use a little animation and keep it light, hopefully keeping your entertainment. I put them in the form of crystals, which is what they do actually look similar to this when you look at them under a polarized light on a microscope. So uric acid is a really powerful thing that I have spent time studying. The places you get uric acid include alcohol, especially malted yeast. The brewer's yeast has quite a bit of nitrogen in it, and the purines or high proteins. We're going to pick up in the middle of the slide deck where if you come to Hack Your Health, you're going to see me go through those two steps first. But we're going to get to the place where we're trying to solve a puzzle in a patient, a case study, and it might be you. The three sources we're looking for, where is this nitrogen coming from? The biggest source, the top three sources, fructose is part of that. The patient that I have, as I'm telling the story about, is from California, and she says, I don't think they allow high fructose corn syrup in my state anymore. It's such a negative connotation for health. Now they do, but it's almost to the regulated burden that high fructose corn syrup, everybody knows that's not what you're supposed to be consuming, that there is quite the link to obesity, there's quite the link to ill health. But what I think is missed in a lot of times when we're talking about high fructose corn syrup, or fructose in general, is that tablespoon of sugar that you sprinkle on whatever you put sugar on. Well, it is called sucrose. It is a disaccharide, two sugars put together, and 50% of it is glucose, and the other 50% is fructose. Now, I don't pretend to bore you with another lecture on sucrose glucose here, but it is a very important process that when you are trying to find energy, I think I'm actually going to switch over here because my slides are going to get different here. Yeah, there we go. It is when you're trying to burn energy through your mitochondria, glucose gives you some pretty fast, rapid burning energy. It is really through that process in your mitochondria that you get adenosine triphosphate, ATP, or energy. And glucose gives you this predictable amount. It doesn't last very long. But if you have fructose, which is very similar, it's got a 5 carbon ring for the shape of this sugar, and it looks very similar to something we talked about last week. But as you process that breakdown of this fuel, it doesn't give you as much energy. It's not ATP, adenosine triphosphate, it's ADP, adenosine diphosphate. But that's not the most important part of this algorithm. The ADP then goes to AMP, and the AMP is uric acid. Yeah, fructose, when you break it down, is uric acid. If you do not break down fructose, you pee it out. You get rid of it in your urine. But if you break it down, it is in the form of uric acid that those nitrogen components are removed, and it helps you eliminate waste. It's a good thing. If I want to prevent you from breaking down fructose, one way I can do that is to block the enzyme that is xanthine oxidase, which is part of that breakdown. And we can do that with drugs called allopurinol, or a much higher potency is febuxostat is the newer version of this. And my goodness, if you're going to try and lower uric acid, those drugs do a good job. So I remind you that when I talk about uric acid, people are like, if anybody in the room knows what the molecule is, they know it because they've had gout. So we know that if fructose is in your circulation, if you have a bunch of fructose, that you will process this, break it down to uric acid, and although ideally you would pee it out, when there's a big sludge of uric acid in circulation, it escapes through the capillaries and gets stored in a very cool part of the body. That cool storing grounds, it classically is known for your big toe, but there are many other places that you'll see it by the end of this lecture that we also put those crystals. So if you've had gout, and I'm watching the chat. I have a question by Jim saying, does the liver store fructose when you eat sugar? No, storing fructose, it will lift it and metabolize it, but the storage version of it is uric acid. So that is that's a good question, actually. All right, so the punchline of what I've learned with lots of books and papers and just really reframing the work of uric acid, we know that fructose triggers the production of uric acid, but that uric acid is a huge stimulus of hunger. You know, last week we talked about one of the hormones for fat. And I'll tell you, you guys didn't like that video very well. It was not one of our best performing videos, but I loved it. It takes you to the third hormone before I talk about this hormone that is really important for converting energy into stored fat or metabolic water. That's what's in a camel's hump. And when you look at the people who have a camel's hump on their tummy, this big beer belly on their tummy, it's stored fat, very similar to this camel's hump. And might it be stimulated? Might it be caused by the fructose to uric acid? That uric acid in circulation stimulating the hormone that really makes us make fat, that is generating the storage of fat. And in my lecture and in lots of the books, you can read about how, oopsie, not that one. You can read about how the evolution that we all break down fructose into the molecule uric acid is allowing us to store fat. And you say, what do you mean allowing us to store fat? Yeah, if you go back in evolution, if you couldn't store fat, you didn't make it to the other side of that famine. So it's a survival component. It just does not play out well in today's world. All right, other things, foraging behavior, much higher when uric acid is present. If we stimulate uric acid, they go eat. Their food intake was higher. They have fat accumulation, and several other of these processes, including higher blood pressure, insulin resistance, is the cause. It is caused in part by uric acid. And this has been a fascinating distraction for me for a year, of which I have had some some little angels coming along and helping me collect even more data about understanding what I don't think the literature is talking about. And we're going to get to that